The global transition toward high-voltage electrification is hitting a physical material limit. High-purity, ultra-thin biaxially oriented polypropylene film is a non-substitutable component in modern power electronics. Demand is modeled to grow at a compound annual rate of 13.1% through 2028. This growth is driven by high-voltage direct current grid installations and electric vehicle traction inverters. Effective production capacity cannot keep pace. The structural deficit for film under 3 microns is projected to reach 15,000 metric tons by 2027. This represents a 20.2% supply shortfall. The gap is structural and widening, driven by the extreme difficulty of scaling specialized chemical purification and extrusion facilities. The root cause of this deficit is a machinery manufacturing monopoly. A single German engineering firm, Bruckner Maschinenbau, controls the production of high-precision tenterframe extrusion lines. Lead times for this specialized machinery peaked at 36 months in 2024, up from 14 months in 2020. The active machine backlog reached 31 units in 2024. A single 10.4-meter-wide production line requires an investment of $45 million to $60 million. Once delivered, these systems require an additional 18 months of on-site calibration to achieve the required chemical purity. This extreme capital intensity and technical complexity prevent rapid supply responses. The supply squeeze is concentrated in the highest specification segments. Electric vehicle traction inverters require ultra-thin films under 2.4 microns to minimize physical volume while maintaining thermal stability. This segment is growing at 16.2% annually, with demand projected to reach 35,000 metric tons by 2028. High-voltage direct current transmission grids require thicker, highly uniform films to handle continuous megawatt-scale loads. Alternative polymers like polyethylene naphthalate cannot easily substitute for polypropylene. Polypropylene maintains a superior dissipation factor at high operating frequencies. Consequently, Western grid modernization and electric vehicle scaling remain highly vulnerable to this single point of failure material.